Alright guys, Mr. Whiten here, kind of getting back into our regular topics here of rational expressions. The last thing I think we were doing was simplifying these things, things where numerators and denominators could be factored, and some factors would reduce out and cancel out, and that's what caused a hole in the graph, as opposed to just a vertical asymptote. So let's just kind of get into a little more of that and do a few examples here. So for example, let's say we are asked to simplify something like x squared plus 20x plus 36 over x to the third minus 4x. Okay, so basically you want to just try and factor everything you can and see what reduces out, right? So in the numerator, we're kind of doing that old school factoring, factors of 36 that add up to 20. So 18 and 2 I think would work, so x plus 18 times x plus 2. And then in the denominator, it looks like they do have a common factor of x. So we can factor that out, and we'd be left with x squared minus 4. And we do need to recognize that the x squared minus 4 is still factorable. So again, it's the difference of perfect squares, right? So right here we have, up top it was still x plus 18 times x plus 2, but the denominator, we had that x on the outside, and then the x squared minus 4, again it's x plus 2, x minus 2. So that does allow us to cancel out or reduce a factor of x plus 2. So the final simplified version would just be x plus 18 over x times x minus 2. And the restrictions need to come from before you canceled anything. So all three of these factors give a restricted value. And when I say restriction, it means restricted from the domain. X equals 0 from that x there. X equaling -2 and x equaling +2. Okay, because again, those are the x values that make these factors 0. And the one that got canceled out, x plus 2, would make a hole in the graph at x equals -2. Okay, so let's do another example similar to that. Let's do something like x squared minus 2x minus 15 over 2x squared plus 3x. Oops, that's supposed to be an x there. 3x minus 9. Alright, again, you just want to start factoring, because that's the only way you're going to get things to cancel is if you have a common factor. So the numerator looks a little easier, -15, but to add up to -2 would be x minus 5 times x plus 3. But with the denominator, we're going to have to do a little more work, right, because it does start with a 2. So we're looking at the old a times c method. So 2 times -9 would be -18. So can we split that up into factors that add up to 3? I think we can if we do a 6 and a -3. Right, so we could rewrite this denominator as 2x squared. I'm going to split up the middle term, right? Remember doing this before? Into plus 6x minus 3x. And then the minus 9. Okay, so again, if that method was a little confusing before, or it's been a while or whatever, again, all we did was we split that up into these terms here. Okay, and I found the way to split it up by doing that little a times c process. So then what we do is grouping. Okay, and we say, all right, these first two terms share a 2x as a common factor, and we would be left with an x plus 3. Okay, then the next two terms, there's a minus there. The common factor is 3, and when you divide a 3 out, it would become x plus 3 again, and that's good. Now they have the common factor of x plus 3, and the leftover is 2x minus 3. So that's going to be our factored version of the denominator, x plus 3 times 2x minus 3. And it does look like something's going to cancel. So they each had a factor of x plus 3. So our final simplified version, which is said write a simplified version, would be x minus 5 over 2x minus 3. But again, the restrictions do need to come from before we canceled. So we have restrictions, restricted x values, okay, at x equals negative 3. And then the other one, you'd have to set the 2x minus 3 equal to 0 and see what x gets you there. So you add 3 to both sides and divide by 2. Okay, so negative 3, and then 3 halves are, uh-oh, I touched something, or our 3 halves, those are our two restrictions. And just in case they were wondering, the x equals 3 would end up being a hole in this graph, because again, that factor did get canceled out. Okay, this next example is actually just a multiplication problem, basically fraction times fraction. And the idea here, again, is you want to just factor as many pieces as you can, and then see if you have any common factors in the numerator that can cancel something in the denominator. So if we just start factoring one at a time, the 2x plus 4, again, all I can do is bring out a common factor of 2. Okay, times that over, 2 times x plus 2. The denominator on the left here, x squared minus 25, that's the difference of perfect squares. X plus 5 times x minus 5. We're multiplying it by another fraction. Let's say the numerator, x squared minus 5x minus 50. So we could do x minus 10 times x plus 5. And then the denominator there, the 4x squared minus 16. Okay, it may not be obvious, but those actually both are perfect squares. It's going to be 2x plus 4 and 2x minus 4, right? Because, again, 4x squared, this is a perfect square, and then 16 is a perfect square. And since it's the difference of perfect squares, we can just factor it into 1 plus and 1 minus. And then when you multiply fractions, you're basically multiplying everything on the top over everything on the bottom. So we can just start canceling here, and then we'll combine it into a single fraction. But let's see, what can we do? The x plus 2's can cancel. I'm sorry, what am I looking at? X plus 5 on top. Even though it's in the other term, it's still in the denominator, so that'll cancel. And I'm noticing one more thing we can actually do here. Let's revisit how we did this piece here. Because if you notice the way we have it now, 2x plus 4, 2x minus 4, those still have a common factor. So it may be better to get that common factor of 4 taken out from the very beginning. Okay, and it'll become 4 times x plus 2, x minus 2, and I'll tell you why I realized that in a second. But let's rewrite this denominator down here, and let's say we factored the 4 out first. And I'm going to put it in as 4 times x plus 2 times x minus 2. And here's why I noticed that. First off, we should notice there is an x plus 2 up in the numerator, and now there's one in the denominator. But the main thing I noticed was actually this 2 sitting here, and now we have a 4 sitting there. So those can be reduced. 2 over 4 can be reduced to 1 over 2. And now if we kind of just clean up what's left, the numerator just has a factor of 1, and then there's a factor of x minus 10. And the denominator, there's still that 2 sitting there. There's a factor of x minus 5, and there's a factor of x minus 2. So that would actually be our new simplified form. And that would be how we reduce all of these. As far as restrictions on x, we need to go back and look at each of the denominators and do what we've always done. Okay, say which values would make it 0. So do that. I would do that up at this point before we canceled anything out, right? So x equaling negative 5 is a restricted value. X equaling positive 5 is a restricted value. Negative 2 and positive 2. So those are your restrictions. And it looks like from things that canceled, the negative 5 and the negative 2 would be holes in the graph, and the other 2 would be vertical asymptotes. All right, and one more example then, a division problem dividing a fraction by a fraction, if you remember division of a fraction, we're just going to end up multiplying by the reciprocal. So we're going to end up doing the reciprocal of that term on the right. So let's start factoring though a few things first. In the denominator on the left there, again, it has a common factor of 3. I'm going to factor that out and get x squared minus 9. Okay, and remember, it's going to become multiplying by the reciprocal, right? That's how you divide a fraction, isn't it? So this is actually going to become the numerator because I changed it to a multiplication problem. So factoring the x squared minus 2x minus 3, we should get x minus 3 and x plus 1. And then factoring the, let's get the color here, the 2x plus 2, all I can do is factor out a common factor of 2. And it would be times x plus 1. One more thing I could factor here, the x squared minus 9 will become x plus 3 times x minus 3. Okay, so we got that reduced. So everything's factored as far as it can go. Now we can treat it just like a multiplication problem. We're going to start looking for any common factor in the numerator, which can be canceled in the denominator. Okay, so let's see. What can we do? Anyone see a x minus 3 over an x minus 3, an x plus 1 over an x plus 1? Let's see here. The denominator, take a look. There's a 3 and a factor of 2, so that really multiplies to be 6. And there's a factor of 6 in the numerator, so those actually cancel each other out. They're all just gone, which is good. We like to reduce things. So our numerator, the only thing left is x squared. The denominator, it looks like the only thing left is x plus 3. Okay, so that would be our simplified version. Now we just got to watch for any restrictions, and this one we got to be a little careful. Remember, anything that makes a denominator 0 is a restriction, right? So from the very beginning, actually from the second step here, I see restrictions of x equaling negative 3, x equaling 3. From this denominator, x equaling negative 1. But the one some people miss is that in the original problem, this term was the denominator, right? So those are also restrictions, right? Because that was originally there. But we already have those values accounted for. We already have 3 and negative 1 in our list here. So we actually have all of the restrictions, but you do just need to be careful. Make sure you check the original denominator. But then when you do the reciprocal part, this numerator becomes a denominator later too. So really, this whole thing you're dividing by, numerator and denominator, can cause restrictions. So just kind of watch for that. And as we go over homework and stuff, we'll check those out. But again, just a lot of factoring, simplifying, and remembering our restrictions. Okay.